Hello everyone to our Fabweld video about gap analysis in welding. Today we will show you the Fabweld Filler Technology, with which it is possible to calculate the gap formation in welded constructions correctly. The exact gap analysis is the basis for the design of clamps or tack welds. Fabweld is a development environment for the optimal application of the LS-DYNA code for calculation of all thermal joining processes using the finite element method for highest precision with the help of the welding structure simulation. Fabweld advantages: highest accuracy, user-friendly interface for all simulation tasks, wide field of application with exact simulation results, create complex simulation models in no time at all, simulate the complete process chains, designed for weld structure simulation and heat treatment simulation, detect critical distortions, and design and optimize clamping concepts and tack welds. The Fabweld Filler Technology allows the best adaptation to the real conditions during welding. This technology realistically models that components can move freely against each other until they are welded. This makes it possible to represent a gap formation in the simulation at all. This is a prerequisite for designing and optimizing a tacking or clamping concept based on simulation. We first consider the initial situation. In the unwelded state, the plates move freely against each other. A gap is clearly formed here. As soon as the weld pool passes, the movement between the filler metal and the component is frozen. Now we improve the clamping situation by inserting additional clamps at the end of the component and moving the clamp of the stiffener from the lateral position to the top position. The base plate can now only move slightly away from the stiffener. The gap is clearly minimized. Let us consider here the improved clamping situation in the animation. Let us consider a battery tray made of welded aluminum profiles. The middle profile is welded simultaneously on 4 sides. Here we see the top side of the bottom plate of the battery tray. See the end of the profile where the gap formation occurs. We have a vertical and a lateral gap. The vertical gap is nearly about 1.15 millimeters. How to improve the clamp situation? The clamps on the top and bottom side of the middle profile are moved in weld direction to the end of the battery tray. The movement of the middle profile in vertical direction is hindered. The gap cannot form as wide as before. Now the vertical gap is reduced to 0.55 millimeters. On this slide we see the vertical movement from the left and right border of the profiles nearby the weld, on the left hand side before the improvement and on the right hand side after the improvement. And we clearly see the significant gap reduction. Thanks for your attention, and in case you have further questions, visit our website fabweld.de or write an email to info@fabweld.de.